What is quantum computing and how does it work? Quantum computing is an area of computing focused on developing and performing computer technology based on the same theory of quantum mechanics, a fundamental idea in physics that explains how the universe works at a scale smaller than atoms. Computers we use today are limited in power and ability as they can only store information in bits. Quantum computers, on the other hand, are much more powerful because they can solve many complex problems exponentially faster than the current classical computers. Quantum computer is not just a more powerful version of the current computer, it is a different technology altogether based on a deeper understanding of science. To understand why, we just have to look at the bits of classical computers. Computers today use bits, a stream of electrical or optical pulses that represents 0 or 1s. Everything from emails to tweets and to this very YouTube video are essentially just long strings of these binary digits, zeros and ones. On the other hand, quantum computers do not work on this very phenomenon. How do they work? Quantum computers use quantum bits or qubits, unlike classical computer bit, which can either be at a state of 0 or 1. A qubit can be at a state of 0 or 1 and can be in both 0 and 1 simultaneously, and this state is known as superposition. To understand this clearly, let's look at Schrödinger's cat thought experiment. Erwin Schrödinger in 1935 devised a thought experiment that goes like this. If a cat is placed inside a box with a device that has a 50% chance of killing it, he asked what is the state of the cat? Is it alive or dead? He pointed out that according to quantum physics, the cat is both alive and dead simultaneously at the instant before the box is opened. This, according to quantum physics, is a demonstration of superposition. Qubits can be represented in any combination of zeros and ones. Thanks to this counterintuitive phenomenon, a quantum computer with several qubits in superposition can perform a vast number of potential outcomes simultaneously. The final result of the calculation emerges once the qubits are measured. Once the result is measured, the qubit collapses into the normal state of either 0 or 1. Because of this, quantum computers can solve complex problems without requiring more qubits, unlike classical computers. There is another important phenomenon in the quantum world known as entanglement. In entanglement, two qubits are linked together like pairs across large distances. This concept is exceedingly challenging to conceptualize, and more on this will be discussed some other time. For now, in simpler terms, entanglement can make two qubits entangled with each other. Changing the state of one qubit will instantaneously change the state of another entangled qubit. This happens even if the entangled qubits are separated by very large distances. This concept of entanglement is so strange that once Albert Einstein even called it spooky. Nobody really knows how or why entanglement works the way it does, but it is a key to the power of quantum computers. Qubits, when linked together, increase the power of quantum computers exponentially. The exponential power of quantum computer is so incredible that at 300 qubits you can encode more information than all of the atoms in the known universe. Although the power at this scale for quantum computers remains largely theoretical. Quantum computing is very different from classical computing in how it is operated and even what it is used for. Quantum mechanics, superposition, entanglement, and many others make this very difficult to understand and enable computers to use their exponential power. Although quantum computers can really help explore and uncover the hidden mysteries of our universe. There will be a part 2 of this video that will focus on the broader use of quantum computing and how it will help in many areas of science, as well as the race that is happening in the world right now in achieving quantum supremacy. If you would like to see some more of this, be sure to check out my previous videos and don't forget to subscribe. If you have some future video suggestions, comment down below.